Hello class, and here we have the area of a triangle. We're going to find some areas of triangles and use that to make the law of sines. So we take a look at this first one and we see that our regular area of a triangle formula is 1/2 the base of the triangle times the height, but we can pick different bases. So I'm going to pick side C as my base, and when I do that, what you'll see, if side C is the base, then the right triangle that I'm going to have here, I'm going to think of this little right triangle that's in there. The sine of that angle B is the side opposite it, which is H, divided by the hypotenuse there, which is side A in the triangle, the blue side A. So solving this for H equals A times the sine of angle B. Plugging that in, the formula for H, we replace this with A times the sine of angle B, and we see that the area of the triangle can be thought of as 1/2 times A times C times the sine of angle B. Okay, now moving on, next time we're going to take a look at this and we're going to use the green. So the area this time is going to be 1/2 times the base, but the base is the green side B, and now I need to find the height. So again, we're going to think of a right triangle up here. So we can think of this triangle that's there with a right angle that's up there. There's my right angle. The sine of this angle A is its opposite in that triangle. Notice it's the green H divided by the hypotenuse, which is the C. Therefore, the height is equal to C times the sine of angle A. Replacing that up here, we get C times the sine of angle A. All right, so B times C times the sine of A. Anytime if you need to, press pause, look at it, and I'm going to try to keep moving on as fast as I can here. Our next thing we're going to try to do is use our other one, our other base. So looking at this, we would say that the area is going to be 1/2 the base. Now, the blue side A is going to be the base this time. And so, at first I'm looking at this, I'm saying, where is my right triangle? And the answer is, the right triangle that I'm looking for is going to be that right triangle right there, where there's my right angle. The problem is, I'm thinking of angle C here as part of the triangle. So here, according to our difference formula, the sine of the difference of two angles, we see that formula that's written right here, the sine of the two angles, okay? And then what we do is we say, what if it's 180 minus theta? This is a proof that we showed the other day that if I separate this, this turns out to be, according to this, our last step here is just to simplify that. I think we found this yesterday, that this turned out to be 0 minus a negative. So that is the same as the sine of theta. So what I'm trying to show there is that if this is C, we take a look at this angle right here, and although that second angle is 180 degrees minus C angle C, because I have a linear pair there, in reality, the sine of that is going to be the same. So looking through the eyes of that angle, the sine of that 180, we'll fit it in maybe right over here. The sine of that 180 degrees minus C is the same as the sine of angle C, but in that one, the sine is going to be the opposite, which is, of course, H in blue, divided by, and this time the hypotenuse is side B. So when we solve that, we come up with H equals B times the sine, and I'll replace that 180 minus C with just C. So this is A times B times the sine of angle C. And what we've seen is three different representations of the area of the same triangle. So because it's the same triangle, we will call those all equal to the same thing. And now I'm going to divide everything by 1/2 times A times B times C. Now, 1/2 A, B, and C, it begs that we should look at this and make sure that's not going to be 0. Since A, B, and C are all side lengths, they are non-zero numbers. So this is 1/2 A, B, C there. Divide here by 1/2 A, B, C, and divide here by 1/2 A, B, C. And we see that things cancel. The halves cancel, the B's cancel to be 1, the C's cancel, and I'm left with the sine of angle A divided by side A equals, likewise here, the halves cancel, the A's cancel, the B's cancel, halves A and the C cancels to be 1s. Okay, and this is left with the sine of angle C divided by side C equals the sine of angle B divided by side B. So all three of those things are going to be equal. How do we usually see the law of sines? We call it the law of sines when we say the sine of angle A over A equals the sine of B over B or sine of C over C. Or because, remember that if I told you that this fraction A over B equals C over D, when we cross multiply, AD equals BC, and then if I divide both sides on the next step here, let's say we divide both sides by A, they cancel there, and we divide both sides by C, they cancel there, I'm left with D over C equals B over A. Okay? So the fractions are equal even if I flip them. And that is the law of sine.